Okay, so I'd like to start the second of our Olefins and Polymers Europe Investing in the Future webinar series. My name is Liz Rittvega. I'm the Business Director for INEOS Olefins and Polymers in Europe. And we decided to rerun the content that we had shared with our customers at the K-Show because we know how time intensive the K-Show is and how many of you will have been pulled in different directions and maybe couldn't attend some or all of the day that we ran. So thank you very much for spending the hour with us this afternoon. We would like to issue a very warm welcome to you. As a moment of housekeeping, I just want to let you know that we will be recording the webinar part of today. We will not be recording the Q&A. We will stop the recording. Please remember, though, on the Q&A that there may be competitors of yours in the chat, and remember to abide by all competition law rules when asking questions. If you have a question you don't feel comfortable asking at the end, please feel free to let us know, and we will try to answer your question one-on-one after the event. So with no further ado, I'd like to run through a little bit about what we'll be talking about in this series of webinars. So yesterday, we had a session with some experts on the phone talking about the sizable investments that INEOS Olefins and Polymers is making into a low carbon future. On the one hand, that is investments into low carbon production, into energy savings, into a world scale cracker, which will be built in the Antwerp harbour area, which will have half the carbon emissions of a normal naphtha cracker, and also how the products that we make across INEOS Olefins and Polymers are enabling a transition to a more durable and more circular economy with the investments that we're making in durable products. So that was run yesterday. Today we will be having on the line Arnaud Petitjean and Marco Amici. Here we'll be talking about something that's quite close to our hearts. We believe fundamentally in increasing recycling rates in Europe. And there are several barriers to that at the moment, one of which is how products are designed. And the other is at the end of life, how products are extracted from a waste stream and sorted. And then next Monday, we will have one final session where we will talk about finding good value-added uses for recycled polymers, because without could I ask that people go on mute? Thank you. Sorry, there was an echo there. How if we don't find uses as society for recycled polymers, the recycling chain breaks down. And we at O&P believe there are some very value-added uses for recycled polymers. So we'll talk more on Monday about how we're promoting that and the investments that we're making in designing those products. We'll also talk about how we're investing in advanced recycling for food contact applications. So if you'd like to join us on Monday, please let your INEOS representative know, and we will send you the invitation if you haven't got it already. So moving on to where we find ourselves in today's world. It is a challenging world, and we know that. We're in the middle of an energy crisis, but we're also being confronted almost on a daily basis with new and emerging legislation and more societal pressure to reduce emissions, to increase recycling, to reuse more of society's resources. And this is in line with our philosophy at INEOS, which is to improve and increase recycling rates across Europe and reduce emissions. So we'll talk about that deep commitment that we have today to sustainability and how we can help you with the products that you need for your customers. And the slide isn't moving. There we go. So at INEOS, we believe in making big pledges, but we don't believe in making pledges that we can't live up to or we don't know how we will live up to. So every pledge that we make is backed up with a firm roadmap. So across the top of this slide here, you will see the commitments that, across the bottom, you will see the commitments that we made to in 2019 to achieve by 2025. And we were confident when we made those 4 sizable commitments. We were confident that we could achieve them, and we are now so close to achieving them and so far ahead of 2025 that we're taking those commitments to the next level with our new 2030 pledge, which is that we will incorporate 850,000 tonnes at least of recycled and or bio-sourced polymers into our polymer products by 2030, which is a very, very sizable promise to our customers and society, and again is backed up with a firm roadmap. And over the course of these two presentations today and on Monday, you'll see more about the building blocks that go into making us so confident we can achieve that. This is also overlaid with the INEOS Group commitment to reduce operational greenhouse gas emissions by 33% by 2030 and to reach net zero by 2050. And again, all backed up by firm plans and investment programs. You'll see over the course of the webinar series, you'll see this little graphic a few times, because we do believe that society is becoming more circular. It's no longer societally acceptable to use materials in a linear fashion. And really, in order to do that successfully, you need to have a good degree of scientific expertise. So INEOS are well placed to encourage and develop a more circular society, whether it's down to the feedstocks that we used, how our products are designed, how they're disposed of at the end of their useful life, and how that circle becomes closed. We're addressing every part of this value chain to create a more sustainable future. With this in mind, I'd like to introduce Marco Amici. Marco has a long history in the polymers business across Europe and is running a program to increase the recyclability of products that are used in widespread applications today. So we call this our Design for Recycling program, and I'll give more details on that over the next 15 minutes or so. Over to you, Marco.
Thank you very much, Liz. So first of all, thank you very much for joining us today, and it's a pleasure being here. The topic of this discussion is design for recycling, which is kind of a buzzword today. But let me tell you how INEOS is actually investing to drive it. But let's make first a quick recap. Why is design for recycling for packaging so important, so crucial to our society? You will hear more also later from my colleague, Arnaud Pellijan, but essentially there are 4 points that describe why design for recycling is so important. First one is packaging in the last few years has increased in complexity. We wanted as a society to achieve higher performance with a lower material usage. And this has been very effective, very efficient in many cases, but it has resulted more often than not in structures, in films particularly, which are multi-material structures. Those multi-material structures are very difficult to sort, hence to recycle. We all know about the system today of sorting via infrared, by optics and so on, and multi-material today pose a real challenge. So that's one of the elements around design for recycling. There is also another element which is becoming way more important in the last few years, also thanks to the SUP directive, which is what we call at INEOS the unintentional littering. Unintentional littering happens when packaging separates during usage, and we will bring you an example of what this means. That essentially means that consumers, people, us, we waste resources due to, let's say, a flaw in the design. So for this reason, design for recycling has become vital, crucial, to both prevent unintentional littering and improve the waste sorting, hence the recycling. Now, this is actually the preamble, but I promise to tell you what INEOS is doing on, to promote design for recycling. And what we believe is that we are investing in designed for recycling packaging, meaning design as a strategy, as a clear intent. And we have many activities doing at the moment, running at the same moment. So we'll be focusing, for the sake of time and clarity, on four which we believe are very important to this audience. INEOS is investing in true design for recycling packaging by driving the move towards tethered caps, by investing in a state-of-the-art MDO, so machine direction-oriented blown film line, by designing and scaling up novel resins, polymers, for monomaterial flexible packaging, and last but not least, by bringing a proof of concept to the table, developing a full PE, full INEOS pouches. So let me start with the tethered caps. This is actually nothing short of a market revolution. Tethered caps are essentially regulated by the SOP directive of 2019, which, amongst different things, state that there is a need for a new design connecting the caps to the bottom. And this is actually what tethered means, connecting, attached. Applies to beverage up to 3 liters, beverage containers, of course, and which is pretty much the vast majority. And there is a very tight timeline. The deadline is actually in 18 months from now, the 3rd of July, 2024. This bears a huge cost for cap producer, which has been estimated by industry around 9 billion euro as a new machine, new tools, and so on. And Europe, again, is at the forefront, and other regions, though, like US and Canada and Australia, are having quite a close look on what we are doing. So there is a list of very demanding technical requirements, and I don't want to bother you what is actually the challenge which is imposed on the industry. There are requirements on the number of opening and closing without loss of function, requirements on the shape and form, on the strength. But I want to tell you how INEOS is actually helping this transition. As you probably know, INEOS is the market leader in cap solution, particularly for based on PE, but as well on PP. We have a wide range of monomodal and bimodal grades suitable and already used for tethered caps. We tend to recommend the bimodal grades because those are the ones where the polymer architecture can be tailor-made better for the final need. And in particular, for this industry, we have developed the INEOS LTEC Superstress Cap 508 and the LTEC Superstress Cap 505 HR, which are suitable for carbonated beverages at the same time as lightweighting and tethered, so kind of encompassing the requirements. Now, don't take my word for that, but have a look on the couple of pictures which are in this slide, where we celebrate partnership with some of the key players in the market, like Alma, Betapack, and Tetra Pak. Those are real examples that are in the market made with INEOS solution for tethered caps. Now, this is one part of how INEOS is investing in design for recycling. The other part is on the machinery, which is an important component. INEOS has decided to make a unique investment as of today in the market by purchasing and equipping ourselves with as an only raw material supplier with an inline MDO, so machine direction oriented, multi-layer blown line from the market leader, which is O&P. We believe that amongst the various technologies, blown MDO has the highest possibility of success in the long run for different reasons, and I'm happy to discuss later. The line that we acquire and will equip our technical lab in Brussels is a state-of-the-art, is representative of industrial scale operations. And at the same time, it's very flexible. It can operate pretty much any polyolefin and pretty much any other polymer that are usually used in flexible packaging. The primary aim is to develop novel, recyclable, monomaterial packaging with partners. And of course, we are very open to the right collaborations. On top of that, we are expanding our film testing capabilities with a new center in the INEOS R&D Center in Brussels. So we believe this is the right technology that will find a lot of solution to the issues we are having today on design for recycling, and INEOS decided to heavily invest into that. But to take a step aside, as I said, this is an industrial machine. At the end of the day, is a very important tool to develop together recyclable films, but it cannot be alone. Our expertise, our strength is, as INEOS, is the resin production and development. We are one of the largest polyolefin and olefins producers in Europe, and we have a lot of different technologies. So how the two combine? Let me tell you what is the trade union between this new machine and the resin world. As you probably know, INEOS has a wealth of proprietary technologies, process as well as catalyst. We operate gas phase reactors, both for linear low density, for high density, as well as polypropylene, both homo, random, and impact copolymers, as well as bimodal slurry for HDPE and as well as monomodal HDPE. On top of this technology, we do have our own proprietary metallocene catalyst and different catalyst range. So this is the industrial part. So we develop and industrial manufacture fully recyclable INEOS pouches for dry food and cosmetics, where essentially we took away the polyester, the patent external layer, and replace it with MDO film based on the Altex HD 6009 FA, without any loss of functionality or shelf appearance or processing. This is just a demonstrator, and we are more than happy to, again, listen to your needs and develop together. Thank you very much for your attention.
Thank you, Marco. So I hope after that presentation, it's clear to everybody that we're making steps not only in how our product is made in the first place, but also in helping our customers find the right way to use it in application without losing the fundamental product properties that you've enjoyed for so long. So this is just one of the examples that we have of what we're doing in this space to increase recycling rates. We're also, though, looking with recyclers into improving ways of extracting and sorting materials. And this is what Arnaud Petitjean, who's up next, would like to talk to you about. Arnaud, I'm going to hand over to you.
So good afternoon, everyone. I'm going to take you through extracting and sorting of plastic waste out of the loss stream. And just to introduce myself, I'm in charge of securing feedstock coming from renewable sources and recyclable sources within INEOS Europe. So in order to prevent that all the efforts that Marco described in the previous presentation getting lost by all the product being burnt or in landfills, we need to change the situation. Indeed, what is happening today in Europe? So if we look at the data published by Eurostat on the packaging waste, what we can see is that the recycling rate remains a concern at a low rate of 42% only. And if the production of, the recycling of plastic packaging in Europe have increased by 4.7 kilograms per head between 2009 and 2019, the production of the same packaging waste have increased by 6.7 kilograms during the same period. So it is a constant fight to basically increase the recycling rate of the plastic wastes into the streams. There are still today too many plastics ending up in incineration and landfilling. That's about 60% of the product packaging that is ending up there. So there needs to be a significant change happening into the industry to avoid this to be burnt or landfilled and creating a lot of CO2 emissions in the same time. This is also representing an important source of feedstock in the future for our industry. And the industry is looking at this waste due to its large capacities of handling the waste and also the means that it can develop. So we believe that the petrochemical industry has a very valuable role to play in increasing these recycling rates. What do we base it on? We'll base that model on creating a virtuous circle. Indeed, today, most of the incinerators in Europe face a problem with plastic. Plastic has a too high calorific value, And by burning the amount of plastic that they burn today, they have to reduce their capacity. So by extracting the plastic from the incinerators, what we will do, we'll first turn the plastic from waste and energy into valuable feedstock for the industry. We call it creating a virtuous circle because by doing so, the capacity of the incinerator will increase and they will attract part of the waste that are currently going to landfilling. So overall, we'll reduce the landfilling of the waste and the plastic in particular. The second thing that by doing so, we obviously increase also the amount of plastic that we can reach because we'll not only get what is today going to the incinerators, but part of what is going today to the landfill. And finally, the other benefits is that we increase the incinerator economics. Incinerators are paid by the volume of waste that they handle. Removing the plastic with its high calorific value from that stream will enable the incinerators to handle a lot more waste and therefore improving the economics. And additionally, we also contribute to reducing the CO2 emission linked to the burning of the plastics. But this is not the only step that we need to do because what's happening is what we extract from the waste are mixed plastic. So it is a kind of soup from polyolefin, polystyrene, PVC, polyamide, you name it. There's a lot of different sources of plastic and type of plastic that are into the thing. So the step that is needed is sorting the mixed plastic waste into usable fraction by the industry. So from the mixed waste plastic, you can extract polyethylene, polypropylene, PS, or other material. And what has happened recently is there's been some huge development on the sorting technology. As Marco mentioned, the use of infrared enables now to sort the waste into different fractions of plastics. But also for our industry that is used to handle, I would say, large capacities, the capacities of the machine has significantly increased in the recent years, which make them now suitable for the kind of size that the petrochemical industry is looking for. So those two changes enable us to clearly look at this mixed plastic waste as a feedstock for the future. Well, we need to do more, and INEOS has a unique position in this. So what has happened so far is the recycling are focused on the easier ways to handle. They relied on the consumer at home to decide what was recyclable and what wasn't recyclable. And unfortunately, by doing so, a lot of plastic still end up into the black bin. We also have seen in recent years that there was a shortage of recycled material, and the price for recycled material is really high at the moment, preventing some of the recycling that we could do on an economical basis. So we truly believe that a change is unavoidable on the market and that we need to increase the recycling rate. And INEOS is a natural choice for handling the mixed plastic waste because we had in-house 4 different businesses, between INEOS Olefins Polymers Europe, INEOS Styrolution, which is focusing on the polystyrene, INEOS Aromatics, which is looking at the feedstock to produce polyethylene terephthalate, or PET, and Innovin that is working on PVC. We got here a unique position in Europe, and therefore we can handle in-house about 90% of the fraction that will come from mixed waste plastics into our businesses. What is the benefit of the INEOS concept? Well, first of all, as I said earlier, we aim at increasing the recycling rates. And here on mixed waste plastic, we talk about a potential in Europe only from packaging of 10 million tons of mixed waste plastics. Also, by developing this concept, we will have a new supply chain that will secure feedstock for INEOS for the future. Finally, by working with sorting machines, and the new technology, we will guarantee supply of quality PCR, and those PCR will be tailor-made for the recycling activities that we intend to have downstream, such as mechanical recycling or advanced recycling. And this is important because some particular qualities are required for those processes. And using our 4 businesses, we will be able to develop an offer of material containing recycled material into our customers' portfolio. Finally, what is also important, by preventing those plastics to be burned, we will contribute to the decrease of the CO2 emissions linked to the burning of these plastics. Is that the end of it? Well, no. I mean, we do still face some issues in sorting plastic, such as PP. At the moment, PP, when you extract plastic from waste plastic, PP is composed of a mix of homopolymer, random copolymer, and impact copolymer, for example. And this is making it quite difficult to handle into our industry. So there are new technologies being developed on the sorting, such as Next Loop or Holy Grail, which use a kind of watermarks on the packaging item itself. So what is a watermark? It is an invisible mark by the eyes of the human being, but that could be read by machines, which enable you on the machine level to know exactly what is the composition of the item. And therefore, by reading this watermark, we will increase the efficiency of the sorting down to almost the homopolymer level, for example, or impact copolymer from injection. So that is clearly solving the issue, as the example given of the separation of PP. It will lead to improving the quality of the PCR further, and therefore also increasing the recyclability of the material. And INEOS, we decided to be partner of Holy Grail and Next Loop PP because we believe of the better improvement that those technology will bring to the recycling world.